In this problem, we are provided with a table of values for f of x, and we are asked to determine if f of x is a perfect square. Since we're provided with a table, let's enter that table into Desmos and generate some equations to represent f of x. So let's go over to Desmos, and I've already added the table by clicking on the plus sign and then clicking on table and then entering the data. Now, we could look directly at the vertex form, or we could look at standard form and decide if it's a perfect square. Let's just look at standard form first. y1 tilde ax1 squared plus bx1 plus c. And that gives me my parabola, which notice my vertex is sitting right here on the x-axis. So that's kind of telling me that's a perfect square because the vertex is sitting right on the x-axis. I also know that this parabola was just shifted to the right 4, so using what I learned about transformations, I'm thinking the equation of this is y equals x minus 4 squared. But let's look at the parameters that the Desmos returned to us for our standard form, which is a equals 1, b is negative 8, and c is 16. So let's go over into Word and build our equation. So it is y equals a was 1, so that's x squared, b was negative 8, so minus 8x, and c was positive 16. We know that in standard form, if we have a perfect square, the c must be positive and a perfect square. Here, c is positive, and c is a perfect square. So I'm leaning towards the fact that, once again, this is a perfect square. Let's double check our relationship between c and b. In a perfect square, we know that b divided by 2 squared must equal c, so let's check. Negative 8 divided by 2 squared is negative 4 squared, which is 16, and that's our c value, so this works. So we could build our equation from this as y equals x minus 4 squared. And again, we can look at this b divided by 2 value. That's what goes in as our h in our standard, in our vertex form. So here's what we think. The vertex is a double root at 4, 0. That was shown on the graph. When we graphed it, remember our parabola looked like this, and its vertex was right here at 4, 0. So it only has one x-intercept, which we call a double root at 4, 0. This forms a perfect square that can be modeled by this equation, and we'll go back to Desmos in a minute and just have it generate the vertex form equation for us just to make sure. The vertex is definitely not the y-intercept, it's the x-intercept. And here our y-intercept is not a perfect square, that is false. 16 is a perfect square because it's equal to 4 squared, okay? Let's just jump back over to Desmos real quick and ask it to create the vertex form for us. y1 tilde a parentheses x1 minus h squared plus k. And here a is 1, h is 4, and k, it's reporting this really yucky decimal, negative 6.2396 times 10 to the negative 15th. That is just 0. So my k value of 0 tells me this is a perfect square, and it is the equation y equals, with a is 1, so x minus 4 squared.